Good morning. Today we're going to talk about Math 101 and in particular Chapter 1.9 or Section 1.9, Chapter 1, Section 9, which is entitled Exponents, Parentheses, and Order of Operations. A topic certainly we've seen before in our mathematical careers. Well, as a brief motivation and review, what is x to the nth power? Now, if I take some suitable base x and raise it to the nth power, really it's a shorthand for multiplying n factors of x. All right, so really we're multiplying x by itself n times. I'll write this down a little more formally as n factors of x. But I'm betting we all knew that. If I look at example 1 on page 69, well, we've actually got 6 parts to example 1. I'll do part A first. They ask us to evaluate 3 squared. Well, hopefully not a big deal. 3 squared means 2 factors of 3 being multiplied together, and of course that's 9 as my result. Part B gives us 2 to the 5th power. For this example, well, 2 to the 5th power is nothing more than shorthand for 5 factors of 2. And 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So 2 to the 5th power gives us 32 as a final return. Let's look at part C for the same example. Example 1 on page 69. 1 to the 7th power, well, really 1 to any power is, of course, 1. When you multiply 1 by itself, of course, you get 1. So if I take 7 factors of 1 and multiply them, well, of course, I'll get 1. So please note that 1 to any power is 1. Let's look at part D for this example. Minus 6 squared, well, if I square minus 6 or raise minus 6 to the 2 power, that means I multiply 2 factors of negative 6. And of course, from our section on multiplication of real numbers, we know that negative 6 times negative 6 is positive 36. Part E in this example, we've got minus 2 cubed. Well, notice in the previous example, when I raise a negative base to an even power, I'm going to get a positive return. And of course, when I raise a negative base here to an odd power, of course, I'm going to get a negative return. All right, so negative 2 to the 3rd power, that's negative 2 times negative 2 times negative 2. Of course, we don't have to always be so formal. Minus 2 times minus 2 is plus 4, and plus 4 times minus 2 is negative 8. So minus 2 to the 3rd power, or minus 2 cubed, is negative 8. One more part to this example, part F. Here we've got a fraction raised to the 2nd power. Well, don't panic, and especially don't run to the calculator. 2/3 squared, or 2/3 to the 2nd power, is nothing more than 2/3 times 2/3. Of course, there's no cross-canceling that can go on here, so I'm just going to multiply across. Upstairs, 2 times 2 is 4. Downstairs, 3 times 3 is 9. So 4/9 is my final return for that example. All right, note, if I've got x to the 1st power, well, that's just one factor of x, really not multiplied by anything. So when there's no visible exponent in our expressions, we assume the exponent is 1. All right, so x, of course, we'll just assume is x to the 1st power. Examples. of exponential notation. Well, let's see if we can simplify some items. This is from page 69, or really an unlabeled example on page 69. And we've got similar to the last example, 6 expressions to work on. Let's say I've got x times y times x with implied multiplications between all these variables. Well, if I've got 3 factors of x, I can group them together. Multiplication is commutative, multiplication is associative. That means I can multiply these factors in any order I like. So I can claim that x times x is indeed x to the 3rd power. So x cubed, or x to the 3rd power times y, or our author would probably write the final answer like this, x cubed y, with an implied multiplication between the x and y variables. How about part B? Again, same example, unlabeled example on page 69. Let's try x times y times z times y. All right, we've only got one factor of x here, so I can't join it up with any other power of x. So I'll just leave one factor of x in my final answer. Y times y is y squared. Again, I can multiply these factors in any order I like. And z times z is z squared. So x, y squared, z squared would be our return for this sub-example. Let's look at C. Again, this is letter C on page 69 in the unlabeled example. 3 times A times A times B times B times B. Well, here we've got a constant introduced into our expression. Well, 3 doesn't really join up with anything here, so I'll just put a factor of 3 in my final answer. A times A is A squared. Grouping powers of B together, B times B times B is, of course, B cubed. So, it's a 3 there. So, B times B times B is 3 cubed. I'm sorry, B cubed. Did I say that right? B times B times B is B to the 3rd power, or 3B cubed. So final answer there for C, 3A squared B cubed. How about D? 5x y times y times y times y. Of course, this can be simplified. There's only one factor of 5 here. There's only one factor of x. And of course, y times itself 4 times is y to the 4th power, 5x y to the 4th. 2 more in this example on page 69. Part E says, deals with 4 times 4 times r times r times s. Well, I know that 4 times 4 is 4 squared. R times r is r squared. And one factor of s remains. I would probably simplify this finally and say 4 squared is 4 times 4. That's 16 r squared s. And one more in this example. F 5 times 5 times 5 times m times m times m. Implied multiplications going on there. Well, 5 times 5 times 5 is 5 to the 3rd power. And of course, m times m times m is m to the 3rd power. 5 to the 3rd power, well, that's 5 times 5 is 25, and 25 times 5 is 125. That's kind of a common power of 5 we're going to be memorizing by our homework practice. So I'll call this final answer 125 m cubed. All right, let's move on. The next topic the book talks about, or subtopic, is difference between minus x squared and this expression, where it's separated by a parentheses, minus x squared. All right, there is a difference between these two expressions, and the author makes a big deal out of this because students tend to mix these up all the time. All right, so please note, if I'm looking at minus x squared with no parentheses, that is equivalent to negative 1 times x squared, or an x squared expression with a coefficient of negative 1, and that's going to be the negative of x times x, will it not? All right. In contrast, let me do this in a different color. In contrast, if I've got minus x squared, well, that is because that base is got a negative sign contained in its parentheses, it's really minus x times minus x, and we know that a negative times a negative is a positive, so it's going to be positive x times x. All right. So, for example, let me squeeze this on the bottom here. If I've got, put this in orange, kind of an orange color on the bottom. If I've got minus 3 squared, the negative of 3 squared, well, the idea here is that this is equivalent to having really a negative, or a set of parentheses around that 3 squared first. Let me do that again. Minus 3x squared. All right, here we go. Minus 3 squared, x squared minus 3 squared, is really equivalent to the negative of 3 squared. That's negative sign is outside the exponent operation. All right, and that will return a negative 9. All right, in contrast, let's try the square of minus 3. Please notice the difference between these two expressions, minus 3 squared and the square of negative 3. This really is equivalent to the square of minus 3, or minus 3 times minus 3. And of course, we know that a negative times a negative is a positive return. Positive 3 times 3 is 9 squared, or just 9 squared for a return here. Okay? All right, let's look at an example in the book. Maybe that'll clear things up a bit more. Let me get a fresh screen here. Hang on. All right. This is example 2 on page 70 in our text. All right. Part A says evaluate the following, minus 5 squared. Well, just like our previous example, it's minus 5 times 5, which is negative 25. Okay. Part B in this example, minus 5 squared. Now notice that base has got a negative sign tucked inside of it. All right, so it's the square of negative 5. I've really got two negative factors here, and of course that's going to be positive 25, or just 25. Part C in this example talks about negative 2 to the third power. All right, and again, that is really equivalent to putting a parentheses, invisible parentheses, around 2 to the third power. So it's the negative of 2 cubed, which is negative 8 as the return. So please beware that negative sign you see in part C is outside of the exponent process. All right, somewhat similarly, well, again, minus 2 to the third power. That's going to be 3 factors of minus 2. And if I've got 3 negative factors, of course, when I multiply them together, I'll get a negative return. Negative times negative is positive, and then positive times negative will give me a negative result. So minus 2, in parentheses, raised to the third power turns into a negative 8. So notice in parts C and D that you do get the same return whether the negative is in or outside of the parentheses. Okay? How about minus 2? Let's see, this is A, B, C, D. All right, the next example is example 3. Example 3, again on page 70. They give us a similar example. Minus 2 to the 4th power. And part B, they give us, again, minus 2 to the 4th power. Now, those sound the same, but again, tucking that negative sign inside the exponent process does change our result here when the exponent is even. Minus 2 to the 4th power, well, again, the implication is we do 2 to the 4th power first and then negate. All right, so 2 to the 4th power, well, that's 2 times 2 times 2 times 2, and that's 16. So our return is going to be negative 16 for part A. How about part B? Well, this is minus 2 inside the parentheses raised to the 4th power. And I'm going to write this out to make it crystal clear, hopefully. Minus 2 times minus 2 times minus 2 times minus 2. Well, if I've got 4 negative factors being multiplied, of course I'm going to get a positive return. Negative times negative is positive. And 2 times 2 times 2 times 2 is 16. So the result here is positive 16. So note the results. The results for A and B are different for both of these examples. Okay? All right, let's talk about order of operations now. Order of operations. All right, I hope we all know about PEMDAS, and please excuse my dear Aunt Sally. We'll talk about that in a minute. What I really want to do is motivate this topic with a simple example. Let's say I ask us to evaluate this expression, 2 plus 3 times 4. Well, I suppose you could get 2 different answers if you would, depending on which operation you do first here. If I do the addition first, and I'll do that over here, 3 plus 2 is 5, and then 5 times 4 is 20. And if I do the multiplication first, I'll do this part over here. Well, 3 times 4 is 12, and 2 plus 12 is 14. We get 2 different answers. Now, we've got to agree on some organized hierarchy of operations here so we get consistent results for each problem. I'm going to say this is the wrong choice, as you probably knew. In this scenario, we're going to agree to multiply first and then add last. All right. Label this order of ops. Parentheses. Operations take hierarchy over all other operations, so we do those first. Then exponents comes next on the list. And M/D, that means multiplication or division, whichever comes first, left to right. So if all you're worried about is multiplication or division, you indeed work left to right. Similarly with addition and subtraction, you don't always do addition first. It's addition or subtraction, whichever comes first, left to right. Again, if all you're worried about is addition or subtraction, then we do those 2 operations left to right, okay? All right, so there's a brief outline of order of operations. Of course, our textbook is more formal about it, and you might want to look there if you've got any confusion. All right, so 14 is the correct answer here. Multiplication before addition. Let's look at some examples in the text. Example 4. This is on page 72. 6 plus 3 times 5 squared minus 4. All right, so if we remember PEMDAS, all right, well, let's see. We've got a bunch of numbers here and a bunch of operations. I think we'll do 5 squared first. There are no parentheses, right? There are no parenthetical operations or operations wrapped in parentheses, so we can skip over that level. 5 squared is the only exponent I see, so I'm going to write 6 plus 3 times 5 squared is of course 25, and carry on to the next line. All right, now we've got an addition, a multiplication, and a subtraction. Which gets done first? The multiplication gets done first, right? 6 plus 3 times 25 is 75, and all the other operations are left pending. All right, now we've got additions and subtractions. Now, remember, when you've got just additions or subtractions to deal with, we do them in order, left to right. So 6 plus 75 gets done first. That's 81. And 81 minus 4 then is 77. Final result. All right, that's example 4, page 72. Let's look at example 5. That's also on page 72. This one's a little nastier. Copy it right. Minus 7 plus 2. Excuse me. Times bracket minus 6 plus parentheses 36 divided by 3 squared. All right, so we've got a lot of numbers here and a lot of different operations, and we've even got nested parentheses or nested symbols of grouping. All right, so symbols of grouping are parentheses, like parentheses, brackets, braces, things like that. Work from the inside out. Probably the best advice, best informal advice we can give. All right, so really I want to go inside these most inner parentheses first, and looking in there, I see an exponent and a division, and of course the exponent always gets done before the division. And I'm going to leave all other operations pending. Don't do this 7 plus 2. This gets done last, really. And 36 divided by 3 squared is 9. And close the brackets. All right, I'm still going to work on the innermost set of parentheses here. 36 divided by 9 comes first. $36 divided by 9, of course, is 4. All right, again, that minus 7 plus 2 gets done last. So many students try to jump the gun on this operation here, so please don't let that happen to you, especially on test day. All right, leaving this operation pending. Minus 6 plus 4 is going to be negative 2. All right, so that takes care of all the operations within symbols of grouping. Now what? Well, I've got an addition here. I've got an addition here and a implied multiplication here. So which gets done first? Well, of course, the multiplication gets done first. Don't do this plus minus 7 plus 2. That gets done last. 2 times minus 2 first, okay? All right, so minus 7. Hang on. Minus 7 plus 2 times minus 2 is minus 4. And now I take care of this addition. So tempting to do that first, or even before you're supposed to. That's the last operation. Minus 7 plus 4 is negative 11. All right, let's get a fresh screen here. All right, let's look at example 6 on page 73. Again, another order of operations problem. All right, we got a lot going on here. We got 1, 2, 3, 4, 5 numbers, and 1, 2, 3, 4, 5 operations going on, and really only one operation gets done first. I suppose technically I should do 8 divided by 2 first, because it's a parenthetical operation, but I can also do 5 minus 2 here at the same time, because they're separated by an addition sign, can I not? So I don't insist that you write a new line of code for each and every step. On some of these problems you'd be here all day. So let me do 8 divided by 2 first, and that's 4, plus 7 times 5 minus 2 is of course 3, and don't forget it's 3 squared. Alright, so here I've got now an addition, a multiplication, and an exponent going on here. Of course, the exponent gets done first, so I'm going to do 3 squared first. All right, so 4 plus 7 times 3 squared is 9. Now what? 4 plus 7? No, this gets done last. Please wait to do that addition. 4 plus what? 7 times 9 is 63. And of course, 4 plus 63 then is 67. Okay? That's example 6. Let's do example 7, same page. Again, a little nastier. Minus 8 minus 81 divided by 9 times 2 squared plus 7. All right, we got a lot going on here. No parentheses, so looks like I'm going to do exponents first. And there's only one exponent operation here, at 2 squared, and that's going to be, of course, 4, leaving all other operations pending. Okay, it's a 9 there. All right, what next? Well, we got subtraction, division, multiplication, and addition. Again, it's multiplication or division, whichever comes first, left to right. Remember, PEMDAS in this fashion. And if you're reduced to multiplication, division, addition, and subtraction, which we are here, I'll do multiplication or division first, whichever comes first in order left to right. So looks like division is going to be the next step here. So I'll do minus 8 minus 81 divided by 9 is of course 9. And leave all the other operations pending. Everybody okay with that? 81 divided by 9 is of course 9. Don't forget to put that negative sign in front of it. Okay, maybe I'll make it a little clearer here. 81 divided by 9 is 9. All right, so I'm left with minus 8 minus 9 times 4 plus 7. Now I've got subtraction, multiplication, addition. Of course, the multiplication comes first before all the additions and subtractions. 9 times 4 is 36. Don't forget about that negative sign in front. Minus 8 minus 36 is minus 44. And minus 4 plus 7 then is minus 37. Final answer. Okay. All right, let's look at example 8 on page 73. Actually, there's two sub-examples here. Let me write them both out. Minus 4 plus 6 divided by 3. And, it's minus 4 squared plus 6 divided by 3. And then contrast this with part B. It's minus 4 squared, but the minus 4 is tucked into parentheses, plus 6 divided by 3. All right, clearly the exponent gets done first in both of these expressions, but beware, this negative sign here in this expression is happening outside the exponent process. All right. I'm trying to make it better and I made it worse. Hang on a minute. All right. So 4 squared is 16, so I'll write negative 16 here. We talked about that earlier in the lesson. All right, I've got an addition and a division. Of course, the division then gets done next, so minus 16 plus 6 divided by 3 is 2. And minus 16 plus 2 is, of course, negative 14. Final answer. Let's look at the B part with these parentheses, including the negative sign before the exponent operation. So minus 4 squared is positive 16 plus 6 divided by 3. And we'll get a very different answer here. 6 divided by 3 comes next. 16 plus 2, and 16 plus 2 is 18. So please notice whether you have the negative sign inside or outside the base of an exponent expression makes a big difference in your answers. Okay. All right, let's do some examples with the some fractions. This is example 9. Oh, bear with me here. I forgot what page it's on. Let me find it here. 1.9. All right, this is on page 73 as well, at the bottom. 9, page 73, that's it. So, evaluate. Evaluate means get a value out of it, right? Evaluate 3/8 minus 2/5 times 1/12. All right, what am I going to do here? Well, you've got a negative subtraction here and a multiplication here. Of course, the multiplication is going to get done first, right? All right, let me rewrite the expression. 3/8 minus 2/5 times 1/12. All right, so this product is what I'm worried about first. Of course, I'm going to cross cancel first. 2 goes into 2 once. 2 goes into 12 6 times. So multiplying now across in these fractional expressions, I'll say 1 times 1 is 1 in the numerator. Downstairs, 6 times 5 is 30. So I'll have 3/8 minus 1/30. Now, of course, to subtract these, I'm going to need a common denominator. And I believe the common denominator, the least common denominator of 8 and 30 is 120. Please note that 120 is equal to 15 times 8. You can verify that by yourself if you like. So 120 is a multiple of 8. And similarly, 120 is a multiple of 30. 30 times 4 is 120, right? All right, so 120 is a number that's a multiple of both 8 and 30, and it is the smallest number that is a multiple of both. So hence the least common denominator. All right, I'm going to multiply top and bottom of this first fraction then by 15. I want to get a 120 as a common denominator, right? 15 times 8 is 120, of course. 15 times 3 upstairs is going to be 45. Minus, and of course in the second fraction I'm going to multiply top and bottom by 4. So I'll get 4 in the numerator, and 4 times 30 is 120 in the denominator. So I'm now able to add or subtract the numerators as indicated. I'll get 41 over 120, and I believe that's a final answer. 41 is a prime number, and 120 is, of course, not a multiple of 41. All right, let's talk about evaluating expressions. Let me get a fresh screen here. I'm going to run out. Last topic we're going to talk about today. Evaluating expressions, variable type expressions. All right, let's look at example 11 on page 74. Now, maybe this is a little too simple. Evaluate this simple expression 5x minus 4 for x equals 3. Well, all that means is I'm going to take 3 and plug it in for x in this expression and then evaluate according to my order of operations. Well, this one's a little easy, maybe a little too easy. So I'll have 5 times 3 minus 4. 5 times 3 is 15, and 15 minus 4 is, of course, 11. But I'm betting we all knew that. Let's look at one a little more difficult. Example 12. On page 75, right at the top of the page. And we'll say evaluate the following. We're going to give you 3 expressions here for the same value of x. X equals 3 as in the last example. And the author gives us 3 different expressions. Again, he's hammering on that idea about whether the negative sign is inside the base or tucked into parentheses in a base expression. All right, so let's grind all 3 of these expressions out for x equals 3. Well, this first one's a breeze, right? You just plug in 3 for x, and 3 squared is 9. That's no big deal. How about B? Again, minus x squared means this. You're squaring first and then negating according to your order of operations. All right, so that's going to be the negative of 3 squared. Well, of course, that's going to be negative 9. And part C, minus x squared, where there's parentheses wrapped around that base expression. Well, if x is 3, minus x is negative 3, and minus 3 squared, well, that's negative 3 times itself, and a negative times negative is a positive. Okay? 2 more for the day. Let's look at example 14 on page 75. A little nastier expression here. Evaluate the following expression, 2x squared plus 4x plus 1 for this value of x. And we've got a fraction here for x equals 1/4. Now don't panic and don't run to the calculator. Wherever you see an x in this expression, namely here and here, you plug in 1/4 and then evaluate according to your order of operations. Really not that hard. No reason to panic here if you show good housekeeping. All right, clearly the exponent expression gets done first here, right? What's 1/4 squared? Well, 1/4 squared is 1/16. 1/4 times 1/4 is 1/16. Okay, once that exponent is done, well, then I can do some multiplications here. But just for clarity's sake, let me write it all out, leave all the other operations pending. 2 times 1/16. Well, of course, 2 cross-cancels into 16 8 times. So I've got 1/8 in the first slot, plus 4 times 1/4. Well, the 4's cross-cancel. I'm left with 1 over 1, which is, of course, 1. And then 1 plus 1 is going to be my last term here. All right, so of course I can add these together. 1/8 plus, well, 1 plus 1 is 2. 1/8, I'll need a common denominator. Well, clearly my LCM is going to be 8, or LCD is going to be 8. 2 is 2 over 1. All right, so, well, 2 with a denominator of 8 with a denominator of 8 is 16 over 8, right? 16 over 8 is 2. So 1/8 plus 16/8, now I can add the numerators as needed and retain the common denominator. Final answer, 17/8. All right, last one here. Evaluate. This is going to be example 15 on page 75 in our text. I'll say evaluate this expression, minus y squared plus 3 times x plus 2 minus 5. So we've got 2 variables involved in this expression, but don't panic. I'll say when x is minus 3, and y is negative 2. That means wherever I see a y, I plug in a minus 2, and wherever I see an x, I plug in a negative 3. So let me rewrite this expression, making those substitutions, and now I'll grind it out according to my order of operations. Well, clearly the exponent operation gets done first, and this negative sign is outside the exponent again. So I'll say minus, well, let's see, minus 2 squared is positive 4. So I'm going to have a negative 4 in the first slot, plus 3 times, I'll do this parentheses operation next. Minus 3 plus 2 is negative 1, minus 5. Well, that leaves me, oh, let me put equal signs here. I really should put equal signs between these lines. 3 times minus 1 is then the next operation that gets done. So I'll get minus 4 plus minus 3 is minus 7, and minus 7 minus 5 is minus 12. Final answer. All right, that's the last example I had drawn up. This concludes section 1.9, exponents, parentheses, and order of operations.